In this video, we want to learn about the situation when we have more than one sample, more than one population, like we have two of them. And then we want to know that what's going to be the hypothesis test for the proportion. So we are talking about the population proportion in this video. And also we want to construct the confidence interval. So basically it's case 4. I'm going to write down here is case 4, but the only thing is that we have more than the one sample. Like case 4, that when we have more than one sample. So we said that, okay, so let's go with this step by step. The first step was that, what's the parameter of interest? Parameter of interest is the proportion. Then we said that, okay, so what's going to be the null hypothesis? Our null hypothesis, we would say we want to assume that their proportion are the same. The next one is that what's the alternative hypothesis? So the alternative hypothesis is that their proportion for the population, they're not the same, these two populations. And then step number 4, it was that, okay, so let's talk about the test statistic. So for test statistic, it's going to be P1 estimate minus P2 estimate. In the origin of it, it has like, because we said that X bar minus mu, right? So, or for example, even if you look at for case 4 in the time that we have one sample, we would have P estimate minus P. So here we would say P1 estimate minus P2 estimate minus P1 minus P2. But because we said that P1 and P2, they are the same, so I would remove this one. So originally, in the test statistic equation, we have it like this. So the z-null, when we have more than one sample, it's going to be P1 estimate minus P2 estimate minus P1 minus P2. Like very similar to the time that we had for case 1. We said that X bar 1 minus X bar 2 minus like the delta. Delta was mu1 minus mu2, right? But here our delta is 0. So P1 and P2, they are the same. Because of that, the equation that you would use, it's going to be, this is 0. So it's going to be P1 estimate minus P2 estimate. So that's the original equation was the one that I showed you. Okay, so I have P1 estimate minus P2 estimate. And then for the standard error for the denominator, I would write down the square root of the P estimate. And the P estimate, the equation for it is x1 plus x2 divided by the n1 plus n2, because we have two samples, right? And then times like 1 over n1 plus 1 over n2. Another thing that I want you to consider is that for this standard error, we could write it down like, we can write it down like this, x1 plus x2 divided by n1 plus n2, or I'm going to write down something as a side note here. For this standard error, I can write down square root P1, right, times 1 minus P1 divided by N1 plus P2 times 1 minus P2 divided by N2. So I can say the standard error is equal to this. When P1 and P2, we consider that P1 and P2, they are the same. So instead of P1 and P2, I would write down just P. Like it's like that, I would write down P estimate. Of course, we need to consider like for the P estimate, I would need to consider the value that I have for P1 and P2. So for the standard error, you can consider this one, right? Or you can consider this one. Both are acceptable. For example, whenever we're working with that's my suggestion. Whenever we are working with the hypothesis test, go with this one. It's very straightforward. Whenever we are working with the confidence interval, my suggestion is that go with this one. You will see that it's easier to find out. Both are acceptable. So in the box, in different stats box, you would see that they're going to go with this one or this one, but both are going to give you the same, like the correct acceptable answer. Okay, so here I have my z-null, and then after I found out my z-null, I'm going to try to see that I have my test set. This is the alpha, so it's like 95% confidence interval, so I will find out the alpha. And then after the alpha, I would say that what's going to be the alpha rejection region. So rejection region, it's very simple, right? Case 4 is very similar to case 1 and 2. Because of that, it's very simple. When we understood the case 1 and case 2, case 4 is going to be simple. So then I have my rejection, like in the left side and the right hand side of the Z table, because we work with the Z table. You see that here is Z null, right? And then I would do my calculation. So I would substitute all the numbers that I have and find out do the calculation. And then I will work on the conclusion. So it's like that. I would say that if I'm in the rejection region, like my if Z observed is in the rejection, like less than Z at the half of the alpha, minus Z at the half of the alpha, or greater than the positive Z at the half of the alpha. So I would say I'm the rejection criteria. So I would reject the null hypothesis, which says proportions are the same. If I'm not in the rejection region, I would say we fail to reject the null hypothesis. So that's for the hypothesis test. The next one is the constructing the confidence interval. So I would say construct confidence interval for the populations. So for this one, for constructing the confidence interval, think about it for a moment. Try to write it down by yourself. See if you can do that or not. You can pause the video and try to work on that by yourself, and then come back and look at the rest of the video. I can write down here for you that we are looking for the P1 minus P2. So we want to develop the confidence interval for this, right? What can I do is that I can write it down a little on the right side, because it's a little longer than the one that we had so far. Okay, so P1 minus P2, that's the confidence interval we're looking for it. And we know that we always start with the estimate, P1 estimate minus P2 estimate, right? And then here is minus, and I have the same things. I'm going to write them down. So it's like the P1 estimate minus P2 estimate plus margin of error. So, and then we said that margin of error is some number from the table. So it's the Z at the half of the alpha. Z at the half of the alpha times the standard error. So for the you see how easy it is when we know the concept. For all of them, like case 1, case 2, case 3, case 1, case 2, and case 4, if it was 1 sample or 2 samples, we have the same rule. It was like whatever you are looking for, the parameter of interest, your estimate plus minus the margin of error. The margin of error is some number from the table, like Z table or T table, and then you would times it by the standard error. The standard error is that you can find it with the test statistic. So try to have this strategy in your brain, like engraved it in your brain in a way that whenever you are looking for this confidence interval, you would go the same path, that definitely you're going to find the answer. So it's like that. Okay, so Z at the half of the alpha, and for the standard error, I'm going to write down this one. You can go with that one as well, but let's go with this one. It's going to give us the, it's just easier, but it's okay. If you go with that one, it's okay as well. So I would write down like P1, 1 minus P1, right? And 1, and then P2, 1 minus P2, and 2, and it's going to be the square root of it. And for this one here, again, I would write down P1, 1 minus P1, and 1, P2, 1 minus P2, and 2, and then the square root of it, like this. So this is going to be the confidence interval for case 4. So in this video, we learned about how can we write down the hypothesis test, how can we test the hypothesis, as well as how can we construct the confidence interval. Just remember the same rule that we had before. It's like that if you were interested to find out the upper bound and lower bound, in that case, you would just consider like lower bound. Okay, consider the lower bound of it. Remove the upper bound instead of half of the alpha, you're going to put the alpha. If you are looking for the upper bound, the same. So you don't consider this, just this one. And instead of half of the alpha, you're just going to consider the alpha. So this is for the case 4. So we learned about the how can we deal with the proportion when we have more than one sample, like we have 2 samples or 2 populations and we want to compare them together.